Hey everyone, Mrs. V here, and today we are going to start talking about double replacement reactions. In particular, today we're focusing on precipitation reactions. So let's get the PowerPoint on and let's learn more about this colourful chemistry. Precipitation reactions we've done them in small scale in the practical video, but they produce some of the most amazing coloured substances. So let's have a look at more about these reactions. Precipitation reactions are what we call double replacement reactions. And an easy way to think of a double replacement reaction is that it's a swapping partners reactions. So what we actually have is two ionic compounds. I've just listed them here as AB and CD. So of course the A is the positive ion because you always mention that first, and B is negative, and C is a positive ion and D is negative. So when they swap partners, they're still going to keep a positive with a negative together, because if you try to put two positive ions together, they would repel one another, and the same with two negative ions. So it's always a positive with a negative. So what's going to happen here is that these ions are going to swap partners. So A is going to actually now team up with D, and B is going to team up with C, but C is going to be written first because we always write the positive ion first. So we're going to look at two different kinds of double replacement reactions. First of all, precipitation reactions. This is when you form a solid from two soluble substances, two things in solution. And later on, we're going to look at acid-base neutralization reactions as well. Today, though, just precipitation. So the first thing we need to think about when we're doing precipitation reactions is we need to be able to predict what is in a solution. When I was a young student of chemistry, my teacher used to bring a solution into class every day, plonk it on the front bench and say, what is in the solution? And we had to say which ions were in the solution, and as well remember that water molecules were in the solution. And this used to absolutely terrify us because he was the headmaster and we were very scared of getting the question wrong. But it did teach us to think about what was actually in a solution. So in precipitation, you mix two solutions, and that means you're going to end up with four different kinds of ions floating around together with the water molecules in your beaker or in your test tube. So we're going to practice identifying what the four ions are when we mix two solutions. So in our first example, we're mixing copper 2 nitrate and sodium chloride together. So copper 2 nitrate. What two ions is copper 2 nitrate made of? Well, it's made of copper 2 ions and nitrate ions. So that's two of the ions that are in the beaker. And then sodium chloride. Let's work out what sodium chloride is made of. So sodium chloride is made of sodium ions and also chloride ions. So the four ions that are going to be floating around in the beaker are copper 2 ions, which is Cu2+, nitrate ions, which are NO3-, sodium ions, which are Na+, and chloride ions, which are Cl-. Now that's what you're going to have present in your beaker. Let's have a look at another one. What about if you mixed lead 2 nitrate and potassium acetate together in a beaker? What four ions would be floating around? Let's look at lead 2 nitrate. Which ions make up lead 2 nitrate? Well, the positive ion is lead 2 ions. And the negative ion is the nitrate ion. What about potassium acetate? That would be made of potassium ions and acetate ions. Okay, example 3 is for you to try. So I want you to pause the video and try the example, and we're going to come back with the answer. Okay, so potassium chloride. Let's see how well you did with this. It is made of potassium ions and chloride ions. Barium acetate, let's see what that's made of. Did you get barium ions and acetate ions? How did you go? Give yourself a mark out of 4. Okay, let's move on. So when precipitation occurs, you've got all these ions floating around in the beaker. And if there are ingredients there to make something that's insoluble, then you'll get an insoluble substance or a precipitate forming. So precipitate just means a solid that's formed when 2 solutions mixed. So if you were mixing silver 1 nitrate and sodium chloride, let's see what you would have in that solution. So in silver 1 nitrate, you would have silver 1 ions and nitrate ions. In sodium chloride, you would have sodium ions and you'd have chloride ions. Now, because silver 1 chloride is insoluble, if we have a silver 1 ion meet up with a chloride ion, they will clump together. So you'll get your little silver ion here meeting your chloride ion, and they will stick together and not be able to be separated anymore. And if that meets another silver ion, then that silver ion will jump on here, and then another chloride ion, and then you can have another chloride ion here, and so on and so forth until you've built up a great big lattice of silver ions and chloride ions in that alternating pattern. And when lots of them stick together, you'll actually get a bit that's large enough for us to see, and that's when we start to see a solid forming from the 2 solutions. Now I've got an animation of how this happens. So let's have a look. So in this particular one, we're looking at that precipitation we just talked about of silver ions and chloride ions making these silver chloride. So we've got sodium chloride and silver nitrate, and we're going down to the atomic level. So I'm just going to pause it there, and we're going to note which ion is which. Let's get rid of that. So you can see that the red ones are sodium ions, the green ones are chloride ions, the nitrates are the big ones, and the purple ones are the silver ions. Here they are floating together, and silver ions and chloride ions are clumping together. Notice that the nitrate ions and the sodium ions, they just stay floating around in the solution. They're not doing anything. But gradually the pieces of silver chloride build up, and you can see what we would see in that beaker is that white precipitate. however, there's no possible combination of ions present that makes an insoluble substance, then there won't be any precipitate. The ions won't clump together and they'll just stay floating around and we won't see anything happen. So we would say that no reaction occurred because we couldn't see any signs of a chemical reaction. Now we're going to learn how to predict if a precipitate will be formed. And for that, we're going to need to know which ions are floating around in the beaker and whether or not we've got the ingredients for an insoluble substance. So we're going to need our solubility rules for this that you've been practicing. Let's have a go. Will a precipitate form when lead 2 nitrate reacts with sodium iodide? The easiest way to go about this is, first of all, you just swap the partners. So the lead 2 is going to go with the iodide and the sodium is going to go with the nitrate. So let's swap the partners and see what we've got. So if we swap the partners, we've got lead 2 iodide and we've got sodium nitrate. The next thing we're going to do is check for solubility. So let's look at our solubility rules. And we've got iodides. So we're looking at our iodide row of the solubility rules. And we're seeing where we might find lead 2. Here it is over here. It's in the insoluble section. So lead 2 iodide is insoluble. Let's go back and write that down. So that's insoluble here. And that means insoluble is a solid forming. And when a solid forms, we call that a precipitate. What about sodium nitrate though? Let's go have a look. On our solubility rules, then if we look at nitrates, we see that nothing forms a precipitate and pretty much everything is soluble. So sodium nitrate must be soluble. There's my controls gone. I've lost my controls. Okay, so we found out that sodium nitrate is actually soluble. So to answer the question, will a precipitate form? Yes. And that precipitate's name will be lead 2 iodide. Here's one for you to try. Will a precipitate form when barium nitrate reacts with sodium hydroxide? Pause the video, have a go. Okay, first step, we're going to swap the partners. So barium is going to go with hydroxide and sodium is going to go with nitrate. So let's write down what we have. Barium hydroxide and sodium nitrate. Now, we already found out from our last example that sodium nitrate was soluble. So we don't need to look that one up again, but let's go and look and see what happens with barium hydroxide. So we're looking at the hydroxide row now. This one here. Where do we find barium? Barium hydroxide is in the soluble column. So we're going to find that we don't have a precipitate here because barium hydroxide is soluble. So the answer, will a precipitate form? No. All possibilities are soluble, so there's going to be no precipitate there. One more. I want you to try sodium nitrate and potassium hydroxide. Pause the video, come back in a sec. Okay, first thing, swap partners. Sodium hydroxide, potassium nitrate. Let's write them down. Next one, check the solubility. So nitrates, always soluble. None are insoluble. So let's go and check, see what we found. Okay, so we found that potassium nitrate was soluble because all nitrates are soluble, and sodium hydroxide, if we look in the hydroxides column on our solubility rules, we'll find out that sodium is also soluble. So the answer here, no, a precipitate will not form. Okay, that's all for today. I'm going to see you guys in the next video.